What if you could work with some of the world's most innovative companies, all from the comfort of a remote workplace? Andela has matched thousands of technologists across the globe to their next career adventure. We're empowering new talent worldwide, from Sao Paulo to Egypt and Lagos to Warsaw. Now, the future of work is yours to create. Anytime, anywhere, the world is at your fingertips. This is Andela.
Hello Gophers, welcome to a new session of this conference. I'm glad to be part of a new version of Conf42 Golang. This time I'm going to talk about testing using Go language. The main purpose is to present some alternatives that we can have available and good practices so that testing our applications becomes a common practice in our teams. So whether you are a beginner in the Go language or an experienced developer, this talk could be quite useful for you. To start, I want to introduce myself. My name is Francisco Daines, but I really prefer when the people just call me Dino. I am a principal software engineer at Walmart Chile. I'm working in the artificial intelligence and data exploitation team. When we have a lot of very interesting products, and most of our backend services are developed using Go language. I have experience in different languages like Java, C, JavaScript, and so many others. I'm using Go since 2 years ago, and I am the maintainer of ArcGo, which is a very interesting testing tool that helps teams to check if their applications complies with a set of architectural guidelines. Okay, the first part of this talk is a brief introduction to application testing. In this section, I'm going to talk about why we should test our applications and talking about a few benefits of doing testing, and finally presenting 2 approaches for planning our efforts coding different kinds of tests. So to start, we need to answer the question, why is testing important? To explain the importance of testing, I included this diagram proposed by Ken Beck. The title of this diagram is The No Time for Testing Death Spiral. As you said, is a very aggressive title, and what it means? Well, the explanation is the more stress you feel, the less testing you will do. The less testing you do, the more errors you will make. And then, the more errors you make, the more stress you feel. And this will be repeated once and once again in an infinite loop. This diagram is presented by Ken Beck in his book, The Test-Driven Development by Example. And it's a very common situation when we are doing manual testing. So, to break this loop, one thing that we can do is to have automated testing in as part of our practices. But why automated tests? Well, Ken Beck in his book, in the same book, tries to explain this, and this is the quote. The quote says that rather than apply minutes of suspecting reasoning, we can just ask the computer by making the change and running the test. What it means? Well, the computer can repeat once again the same test battery expecting the same results and in a very, very short time. So we can make an initial effort creating these tests and then changing our application, changing over and over again and running the test, and the expected results should be the application having the same behavior. So we can do this in an easy way, doing automated testing. So what are the benefits of application testing? Well, here we have three. There are a lot of benefits, but those three are the most important, related to application quality. The first is to reduce bugs. Why? Because if we are continuously testing different use cases for our applications, then it's more probably to find bugs and fix them before publishing our software artifacts into production environments. The second one is to improve security. Here we have to think and consider that every bug that we brings into production environment can be increase the risk of a security issue. It's not always that every bug is a security issue, but we have to think and prepare and change our mindset to trying to avoid as much as possible the bugs into production environment. And finally, testing our applications will increase the software quality, because as we can catch some bugs as part of our development cycle, we are fixing them in the same development flow. Our software products will be of higher quality compared to products that have manual testing or maybe doesn't have testing at all. Those three benefits are well known by technical people, but how we can convince business people or stakeholders that expect we as a team will produce different releases very closely one by other. There are two benefits. I titled this slide the ones that really matters, but those are the ones that really matters for business people, for some kind of stakeholders. The first benefit is that testing our applications will save money. Why? Because increasing the software quality will reduce the production errors. And then, if you have less errors in production, we will spend less time in debugging and finding and fixing those issues, so that we can focus our time in adding value to the business. This will save money. And the second one is even more important than the first. Doing testing in our applications will improve the customer satisfaction. Why? Because increasing deployment frequency and releasing higher quality products should improve our customer satisfaction and loyalty. So we can use these two benefits to convince business people for doing testing as part of our deployment and development, of part of our development practices. Well, finally, there are two different testing approaches. Those are the most popular approaches. The first one is the testing pyramid proposed by mycon, and the second one is the testing trophy proposed by ginkgo+gomega. In both approaches, we have different kind of tests. The difference between these approaches is how many effort we will spend in those different kind of tests. mycon focus the effort on have faster feedback from testing, so that's the reason why the unit tests have a lot of tests. This is the representation of having more tests than service tests and UI tests, because are more easy to code and are faster to run. So then we will have a faster feedback. On the other side, ginkgo+gomega prefers to focus our effort in integration testing, because those are the harder and the more complex tests, and then we will testing more realistic use cases. And of course we have end-to-end and unit test and static ones, but there are just different approaches. You can choose whatever you prefer. There is no a rule of thumb to select the right testing approach, because there is no a right testing approach. And this talk is about unit testing, so it doesn't matter what kind or what approach for testing you will select. Well, the next section is testing Go first steps. In this section, we are going to look at the testing tool provided by Go language, and standard package that we can use to create unit tests. So our first steps include knowing two things. First is the Go testing tool. It's a standard tool to automate the testing for desired packages. It's included as part of Go language, so you have nothing too extra to install in your computer. The second one is the testing package, or as the Go testing tool, the testing package is included as part of the Go language. It's one of the standard packages. It provides features to create unit tests, benchmarks, and fuzzy tests, but as part of this talk, we are only use the unit test provided by this package. Okay. For more information, of course, you can go to the GoDoc web page for the testing package, or use the command line go help test for the test the Go testing tool. Okay. We have some minutes to create a demo to use the Go testing tool and the testing package. Okay guys, we have a very simple project for the demos. It's a Hello World project. Here I created an examples package, and in this examples package I created a very simple function. It's an add numbers function, which receives a list of numbers and adds all of these numbers and return the result. To test this function, we need to create a testing file first. By conventions, we try to follow a naming conventions. Is the name of the file followed by underscore test. All the files that ends with underscore test will be used by Go testing tool. Okay. Well, then we need to create a function the name of this function must start with test, and then the name of the function that we are testing. Okay, so we are creating the test add numbers function, and the parameters of this function are one variable of type testing.t. This is used to tell the Go testing tool that this is a simple test, a unit test. Okay, and then inside the test we can set the expected result and set it with a number, for example 55, and then call the function that we want to test. For example, result there be assigned to numbers, and the numbers from 1 to 10. Okay, and finally this check. We need to check if the result is the expected value. So we can use a simple if sentence. If the expected result is different than the given result, then we can tell the test to fail. Okay, and that is we can run the test using the IDE or using the terminal, using the Go testing tool. Go test and passing. Sorry, my mic is having troubles. Passing the root package, and this will run all the tests under this package. Okay, in this case, the Go testing tool is telling that the root package has no test files, and the examples package have some tests inside. Okay, what happens if I change the behavior of my function and, for example, change the return value, and there is not the addition of all the numbers, is adding all the numbers but plus 1. Okay, in this case, if I run my test, the Go testing tool tell me that one test fails. The test add numbers is failing, but just this. I need, most of the time I need more information about what happened, if why the test fails. So in this case, I prefer to not use this sentence, the t.fail, and use t.errorf. With t.errorf, I can pass a message to the Go testing tool. In this case, I can pass expected value and what I got in this test. Expected result and result. So how I can see this in action? Well, we can run the test in the terminal, and as you see, we are having more information about what happens. The test add numbers fails, but the Go testing tool is telling me that on line 11 here I'm raising an error with this message. I'm expecting 55, but I got 56 from add numbers. So I can fix this behavior and roll back this change and coming back to the right behavior of this function. Okay, so I'm going to run this again, and hey, there is all good. This is running all the tests under examples package, and all have succeed. And that's all about this demo. We are creating our first test. This is a very simple test, so we come back and see another topics of this talk. So, what happens if we want to test multiple cases? For example, when we want to test border cases or invalid input values or some common values for a function or unexpected values, and check for the return values that we are expecting for each case. A wrong approach is to copy and paste the test, changing only the input parameters and the expected values. Should it work? Of course, but it's not the ideal. Why? Because we are duplicating code. As you can see in this example, the only thing that we are changing in those two tests are the expected value and the input parameters for the add numbers function. The rest of the test is exactly the same. So we need to find a way to avoid this code duplication. That's why copy and paste the test is not a good idea. But what we can do? Well, the proposal is called the table-driven tests, and the main idea is to define a table with input and expected values, and then translate this into code and test for each row in this table using the same code snippet, avoiding code duplication. As you can see in this example, we are creating a table with input values and expected results, and then translated this into code. Remember, tests are code, so we can create use some common operations from code. In this case, we are using a for loop to iterate over the different rows in this table. So let's go and see how we can create some table-driven tests in our Go project. Okay, in this demo, we will start with the wrong approach to test multiple cases. As you see, I am replicating the same test and changing only the expected results for each case and the input parameters. All of the rest of the test is exactly the same. So we can see that they are almost identical. And what happens if I want to test 100 cases? Believe me, we really don't want to replicate the same test 100 times. So what are we going to do? It's to use table-driven test. To follow this table-driven test, we can create a table containing the inputs and expected values. We can create using a var, for example, add numbers test cases, and this will be a struct and a slice of a struct. This struct contains input values. Input values will be a slice of integers, and expected result that will be an integer too. Okay, this is our struct, and what values we can add here all the test cases. I will change this. Yeah, that's right. We can create different instances to this slice. For example, the first case will have 1, 2, and 3 as the input parameters, and the expected value will be 6. Okay. For the second case, we will use 1 and 100 as the input parameters, and the expected value will be 101. And then we can add another value. So sorry, I'm going to copy paste this for sorry to do this more quickly. 1, 2, and zeros should return 3, then 201 and 403 should return 604, and then another cases, for example 111, 222, 333, 444 should return this value, and finally an empty input to return 0. Okay, what's happening here? Too many values. Don't worry about this, is just the IDE. And then we don't need to repeat the same test over and over again. We need just the add numbers as the base. We can test driven approach and table driven approach. And what we'll do inside this test, well, we need a for loop. This is the test case. We are iterate over the add numbers test cases, and for each test case we will run a test running case, and we will run a function that is the test itself. It's receiving a testing.t, and inside this function we will program the behavior of the test itself. It's exactly the same that we have here, but we will copy just this part and we will use the test case value, test case dot input, passing the input to the add numbers. Well, we need to convert into variable arguments here, and then we don't have an expected result. This is part of the test case dot expected result. Oh, here we have an issue. This is, yeah, that's a problem. Okay, there we have an expected result, and if the case is that the expected result is different than the result from the call to the function, then will we tell the function to fail and passing here test case dot expected result. And the behavior will be exactly the same, but the big difference is that we need much less code, and it's very simple to add new test cases. We need to just add cases to this slice. Okay, how it see in the when we run this, we can run this here and with the ID, and this will show us all the test cases, but maybe we can change this this identification of each test case, and for input, for example, no, we can format a message for input /b and test case dot input. This will be more easy to identify each case. Here, as you see, each case will be we can identify the input parameters for each case. So this is why a table-driven test is a good approach. It's a good knowledge to have, because it will be easy some the test of different use cases. Now we are going to talk about code examples. Examples are code snippets that will be running as tests by Go testing tool, but also are displayed as package documentation, and we can visit and see these examples in the Godoc web page for the package. To create code examples, we need to comply with a naming convention. Our function should start with example and have different conventions for the cases that we need to create examples for functions, type, or methods inside a type. Okay, here are some examples. For example, to create an example for the compare function in the package string, an example for the writer type in the package buff.io, and finally an example for the lines method for the scanner type, which is part of the package buff.io. And how is displayed this example in the Godoc web page, where here is an example of this. This is an example for the contains function, which is part of the string package. This is the link for looking this page, and as you can see, the Godoc web page will display the example and present a very simple playground that we can change some of this code and changing the output. This is very useful to create some examples and test inline how to use a specific function. Okay, this is the time to see how we can create an example. To create an example, we need to create a function that the name of the function must start with example, followed by the name of the function that we want to create this example. In this case, add numbers. This function needs no parameters, so we create this block. Inside the block, the idea is to create an example of how we can use this function. For example, we can create a variable result that is assigned to add numbers, and the values 1, 2, 4. And to tell the examples to work as a test, we need to send a value or a couple of values to the standard output. In this case, we can do this with the fmt package println result. We are sending the result value to the standard output, and the assertion, the check, will be we need to set the output. This is a reserved word in for the example functions. Output, we expect to get the value 10 in this case. So the Go testing tool will run this piece of code, this part of the function, will check that the output, the standard output, receives the number 10. And that's it. The example will be published as part of the Go.doc web page of this package. Well, the next topic is test assertions. And what are assertions? Well, assertions are sentences that must be true. In any other case, our test will fail. There are a lot of assertion libraries, but I prefer the Testify package because it offers a lot of interesting assertions, as the ones I list in this slide. For example, the equal or not equal, to check if two values are equals, by the way, to check nil values, or to check if a slice contains a specific value, to check kinds of errors or the message inside an error. Elements match, for example, allows us to check if two slices have the same values but not necessarily in the same order. And there are other interesting assertions like file system assertions, HTTP assertions, and equivalence between JSON objects and YAML objects. That what it means, that two objects will be equivalent if they have the same attributes and the same values, but not necessarily in the same order. And in the left are an example of using the assert package from the Testify module. And what happens if an assertion fails? For example, in this case, we are checking that the slice contains the var x value, and it does not contain this value, so the test will fail. And what happens? Well, we will get a more readable output with more details. So it's an improvement to find what was wrong with our code. So let's go to a hands-on demo. Okay guys, for the example for the assertions package, first we need to download the Testify package. This is how we can do it. Go get -u to update dependencies and the URL for the package. In this case, I have downloaded before, so it will do nothing, but with this command you can get the Testify package. To create a test to show what we can do with the assertion package, I'm going to create another test, add numbers, but this with assertions. This is another test, and to show you some features of the assert package, imagine that we have two slices. Slice 1, that will be a slice of integer having the values 1, 2, 3, 4, Conf5 and another slice having the same values. And we need to check that both slice contains the same values. To do that, we cannot do slice this slice 1 different than slice 2, because this cannot be doing this operator doesn't exist on Go. So first we will need to create a function that compares those two slices and return if they are equals or not. But the searching package contains a function that will help this. We can call it with equal, and with a message. We need to pass the test slice 1 and slice 2 and a message when the two slices are different. Slices are different. Okay, so to check this, we will run the test. The test will pass because both contains the same values in the same order. If we create different slices, this test will fail, and we will get a very detailed message about what was happening. Okay, with our message here, of course. That's good. It's a very simple way to check if two slices are equals. But sometimes we need to check if two slices contains the same values but maybe in different positions. For example, we can change the second slice, the numbers of the third and the last number of the second slice, and if we run this, the test will fail because the equal checks that both slices contain the same numbers in the same order. To resolve this issue, assert library offers another function that is elements match, and this function check is if the elements of two slices or two objects are the same, and doesn't matter what's the position of each element. So if we run this test, it should be passed. Okay, that's good, and that's a very interesting function. Another interesting function is to assert that a slice contains another specific value. For example, slice 1, we need to check if slice 1 contains the value 3. We will put just a new if it doesn't contain. So we will run the test, and both assertions will pass. Okay, but if we try to check if it contains the number 35, it will fail. That's it fails because the slice does not contain the number that we are expecting. Well, as I said, the testify assert package is not the only option that we have. There are many others libraries like Gomega, assertions, fluent asserts, and so on. If you want to search for more options, you can use the Godoc webpage. Here is the search query, and you can find and look for different options and choose the options that fits better for your needs. Let's talk about test doubles, especially about the mocks and stubs. This is the context that I'm going to use to trying to explain the idea behind test doubles. In the top diagram, we can see a real implementation. We have a SUT, the system under test, the system that we want to test our application, for example, and this system depends on an artifact, has a dependency. This dependency can be a database, an API, a file system, a message queue, or whatever. So this is a very hard to test situation because we depend on an external system. We cannot trust on having the same responses when we create queries for the database, for example, or having the same responses when we request an API, because those systems are externals. We have no control over the content of these systems. Okay, so the idea behind the testing with doubles is that the test suite will call the system under test, as we see in the previous examples. We are calling the functions of our system, but the test suite has to create a double which will be something like a replacement of this dependency, and the test suite can control this double, this replacement. So the system under test will think that this double is the real dependency, and we can test the behavior in a controlled environment, because the test suite can control what answers, what will be the responses of this double implementation. What are the benefits of this approach? Will be easier to test the system under test. We can trust in expected states because the test suite is defined the state of the double. There will be no side effects. We can create, we can delete, we can run the test suite 100 times, and there will be no side effects on the real systems. And finally, the test will run faster because all of the dependency will be controlled inside the test suite. There are a couple of things that is important to talk about the test doubles. The first one is that test doubles are a replacement for some dependency to easy testing. How test double works? Well, the test double merely has to provide the same API as the real dependency, so that our real system, our system under test, think it's the real one. We are creating a replacement, and as we offer the same API, the system under test think that is interacting with the real dependency. Well, we have 5 variations for test doubles, where I will talking about very a resume for each variation. The first one is the dummy object. The focus of this dummy object is just to comply with a function signature. We are not using the content of the object. We are just creating a dummy for comply with the signature, and can allow us to use a function and call a function. The second one is a fake. It's a real implementation. of the dependency, but it's more simpler. Usually takes some shortcut which makes them not suitable for production. For example, a common example is an in-memory test database. In this case, we can create an in-memory test database. We can control what objects or how to populate this database, but it's not ready for production. We cannot publish the application with an in-memory database because we have another system, most robust database as a real dependency. The third one is a stub. It's one of the important doubles that we will focus on this talk. A stub provides canned answers to calls made during the test, usually not responding at all to anything outside what's programmed in for the test. What it means, we can set fixed response for calls to several functions. The next one is spice. In this case, are different from stubs in terms of that spice are focused on how we are calling the functions. We are focused on checking what parameters we are passing in different calls, and that's the idea with spice. An example can be a login service. For example, in this case, we can check what messages are logged, or what kind of login level we are using in different calls. This is an example of spice. And the last one are mocks. They are similar to stubs, but the difference is that we can create different behaviors of the function based on the input parameters. But how we can use stubs? The easiest way to stub a dependency is to implement an object that complies with a required interface. This will be easy if we are following clean code principles. What it means, for example, when we are defining interface to interact with infrastructure components. The example in the left is an example of a poor design, because my business type, which can be an use case, for example, depends directly on a concrete type. For example, in an SQL driver component. In this case, it's really hard to test because this concrete type will call external services and trigger side effects, and this will be really hard to check and trust in responses from this interaction. The case in the right is a better design example. In this case, we are defining an interface, my interface, which defines the signature or the API that all the infrastructure components must comply with. In this case, for example, this SQL driver should comply with this interface. And the business type, the my business type, remember the use case, interacts directly with the interface, not the concrete type. The my business type will not worry about what specific implementation of the my interface is receiving and is interacting with. He only worry about the variable he's receiving must comply with the interface. It's the only that that is important for this my business type. Okay, in this case, it's easy to stub this behavior because in the test we can create a concrete type, a concrete struct that complies with the my interface signature. If we create this type, we can create an instance of this type, a variable of this type, and pass this variable to the my business type. And with this, we can stub the behavior and trust in the responses that the my interface will return to the my business type. Okay, maybe this is not easy to understand when I am talking about, but so let's go and see how stubs works in the code in a demo. Okay, well, the next example is about stubs, and for this case, imagine that we have a concrete dependency. Our software depends on a specific system, and we have here a structure and a method. The method is called doStuff, and when this method is called, we are going to print to the standard output a message, a fixed message, and maybe we can call external services. Okay, maybe an API, or do some queries to a database, or change some values in the file system, anything. Okay, this is a concrete implementation of one of our dependencies. Okay, now for the case of a use case structure, this is an example of a use case that has a poor design, because we are dependent. We have a dependency here, a direct dependency to the concrete type. Okay, this is very simple to program. We will just call the doStuff method for the concrete dependency and maybe do more things. And in the main method, I can call first. I need to create a variable of type my use case, and then call this method, some business logic method, and this will call the my concrete dependency doStuff method. We can test this running this main function, and here you can see that my concrete dependency doStuff was called. Okay, but this design is very difficult. It's hard to test because we have a direct dependency and we cannot control the behavior of this dependency. Okay, so an alternative way is to create an interface. The interface will define all the API for every concrete dependency that our system needs. Okay, in this case, I have defined only the doStuff method, and then do this. We can define our use case. This is other use case in terms of the interface, not in terms of the direct dependency. With this, we can link the some business logic method with the interface doStuff method. Here, the my other use case doesn't for this use case doesn't matter what concrete type of dependency we are working with. This use case just need a concrete type that complies with the signature of my dependency interface. And finally, we can link our concrete type with the interface and assign to this inner dependency. So in the main method, we can call this as use case 2 equals can create stubs dot new, and we need to pass a dependency. Here we can pass a stubs dot my concrete dependency. So if we call my use case 2 dot some business logic, this should run the my concrete dependency do stuff method again. Here we can see that this message is repeated twice because we are calling the my concrete dependency in use case 1 and in use case 2. So why we need to refactor our code using this interface? Because when we create a test here, for example, we can create this use case test file and a function test my other use case dot some business logic method. Here we need to call the first we need to create a use case. So my use case new my other use case. We need to pass a concrete implementation of my dependency interface. So we can create here a type my stub dependency is a struct, and we can create a function my stub dependency do stuff. Oh, sorry. And here we can another behavior. We are changing. This is another implementation of the my dependency interface. Complies with the signature, so we can pass an instance of this my stub dependency yeah, sorry but for the typo here, to the constructor of this use case, and then we can call use case dot some business logic method, and finally some assertions, but we are not to do any assertion for this example. We just want to know how to create a stuff. So let's go and run this case, and as you see here, we are running the some business logic method of the use case, but the do stuff method is from the my stub dependency. So I can control the behavior of the dependency and then what are the expected values that the use case will get. So it's more easy to test some scenarios. Okay, how we can use mocks? Well, remember, a mock is very similar to a stub, but the test will also verify that the object under test calls the mock as expected. Okay, this is represented in the diagram. The system under test will call the mocked object. The behavior of the mocked object is defined by the test suite, because remember, mocked object is a double. And what things we can do with a mocked object? We can define several behaviors given different input parameters. And another interesting thing is that the test will fail if the system under test calls the mocked object with a set of parameters that were not configured. This is a very powerful feature. Well, in this case, I will use Testify as the mocking library. And why? Because Testify offers some useful features. For example, we can control that given several parameters, I want to return some values once, twice, defined number of times, and other interesting features of this library. This is an example of how to the test or the mock object will behave. In this case, the mocked service will return hello only once, only the first time the system under test calls this service. All the next times that the system under test call the mocked service, the my method will return bye. Okay, this is the kind of things that we can do with mocked feature of Testify. But as we are developers, maybe with an examples, with a demo, it's more easy to understand what we can do with mock, and in this case with Testify. I prepare another example, and a little bit more complex example of a dependency. Now our dependency interface defines one method, but this method receives parameters and has a return value. Okay, so our concrete dependency to comply with this signature, so it receives a input parameter and return a string value. Inside this method, we could call external services, and maybe return a response for this from this call. Okay, for this demo, we just return 3 times the input value. It's a very dummy return value, but we are not trying to demonstrate anything in this concrete dependency. So we have this dependency interface. The use case receives an inner dependency using this constructor here. It's very similar to the requirements for the stub doubles, and our some business logic methods receive an input value and do some stuff using our dependency and return the processed value. Okay, so what can do in the test of these methods to mock this dependency? Well, to mock the dependencies, we need to first create an object. This object needs to be an structure and implements the mock interface from the mock package. Okay, and we need to make these mocked objects to comply with the my dependency interface. So we need to add the doStuff method that needs to receive one parameter of type string and return some string value. And this is needed to call the original method with this parameter and return the first returned value to the caller. And how we can mock this object in our test? Well, first we need to create the test, then create a mocked object from the mocked object structure. And then it's the interesting part. We can link a set of arguments, input parameters, with a set of expected values. In this case, we are telling the mock package to change the behavior of our doStuff method, this doStuff method. So when the caller passes the hello as the input parameter, then the doStuff method will return a fixed value, hello world. Okay, it's very simple and it's very easy to understand this logic. So then we can create a use case passing this object, mocked object, to the use case and call the some business logic method with the hello as parameter and storing the message, the returned message, as the message1 variable. And finally, made an assertion that we are expecting hello world, this is the value, for the variable message1. Let's go and see what happened when we run this test. Okay, all pass. This test is pass because we are expecting this value. If we change the expected value, for example by, this will fail, of course, because we are linked the hello input parameter with hello world return value. So this will not be true. Another interesting thing is world is when we pass another value, unexpected input value. What will happen if we pass a value that was not set up here as a linked in the mocked object? Well, then the test will fail and the message will tell us that there is an expected method call because we only are expecting the hello as input parameter. We can create another input parameters and put here an unexpected return value, for example. Running this test, we will get another error because we are trying to compare this message that will be unexpected return value with hello world. So we can fix it with for example here with hello and message2 with the other expected value. Well, this test will pass because we are calling some business logic method and then the doStuff method of our mocked object with the expected parameters. At this time, we had talking about how to create tests, how to use assertions and how to use test doubles to test some hard scenarios, more complex scenarios. But there is another thing that is very useful for us, and it's very important to have in mind always, is where to put the test, where we should create the test. So where should we put our test? There is a convention in Go. Go is a language with a lot of conventions. The Go testing files should always be located in the same folder and package where the code they are testing resides. What it means, for example, if I have my package with a couple of functions and I want to test this function, my testing code should reside in the same directory and use the same package, my package in this case. The Go compiler will exclude all the testing files when building our applications, so we don't need to worry about having testing code into production artifacts. Okay, we should not worry about this. But there is another interesting thing related to the package that we will use in the test. Imagine, for example, that we have my package, a package called my package. In this package we have three functions. The first one is a public function, is my public function, and we have two private functions. Okay, and my tests were located in the my package underscore test.go. So we can choose two options for the package of my tests, even if the conventions tell me that I should use my package as the package of my test. I have two options. The first one is use my package, and in this case I can test the three functions separately, because as the test code is in the same package that the working code, the system under test, I can access all of these three functions. I really don't prefer this case. I prefer the second option. The second option is to use a different package. In this case, the unofficial convention is use the package underscore test. In this case, my test can only access my public function, because as the test code is in another package, the test code cannot access the private functions of the package. There is no right way. I prefer the second one, but the convention is the first one. You have to choose. I really recommend the second choice, because we will testing the interfaces of the packages. So to see this in code, let's go and see some examples in a hands-on demo. For the next example, imagine that we have a public function which depends on two private functions in the same package. Okay, in this case they do some complex operations, should do more complex logic, maybe applying a hashing algorithm or anything, and they complies with custom verification function, can verify if the input value complies with a custom algorithm, for example. So our public functions, the function that will be visible to the rest of our application, depends on these two private functions. If I want to test this package, I can create the do stuff underscore test function. By default, by the convention, my test will be created in the package, in the location package, in the same package, and I will create the function test my public function. Okay, and here can be assertions, for example, I don't know, return response, return value equals to my public function, passing some value, I don't know, forward, and then assertions, and expected will be var, and an assertion will be assert dot equal expected with return value. This is my test, okay? But what's the issue with put my test in the same package than the code? The issue is that I can access the private functions. For example, the do some complex operation. I can do that in and var1 equals to 2, and the test will not fail because I can see these functions because I am located. My test is in the same package than the code. So the recommendation here is to change this package and use the underscore test. And in this case, I need to import the location package to access my public function. But if I try to access the private function, I cannot access this function because it's private. So this is the case to demonstrate the different what happened if I put my tests in one package or in another. The test can be located in the same directory but in different packages using this underscore test at the end of the testing package. So the recommendation is to use this package for the test to test the public functions, and only in the cases that we need to have an exhaustive testing of some of our private packages, use the same package of the code. Okay, this is the recommendation. Prefer use another package to test the public functions. Okay, I want to finish my talk with a brief introduction to behavior-driven development because it's a topic that I think it's very useful for us and very interesting too. What's the motivation behind behavior-driven development? It's to focus on the gap between specification and coding. What it means? When we specify our software, we are talking about user stories, acceptance criteria, and those artifacts commonly are defined in terms of human language. Maybe sometimes using Gherkin syntax, this group of give and when then, you know. And for the other side, we have a test suite that is a group of many tests, but those tests are commonly created based on plain Go language. So it's hard to match a couple of acceptance criteria with a couple of tests. It's not easy. So the idea is to have a way to make easy the match between acceptance criteria and test. And then behavior-driven development uses a simple DSL, a domain-specific language, to convert structured human language into executable tests. Okay, so the idea is to make easy the task to match between acceptance criteria and every related test to this related to this acceptance criteria. Well, there are many testing frameworks that offers behavior-driven development style. I prefer ginkgo, but there are others like Golang, Goblin, Mao, and Zen. So you can choose the one that fits better for your requirements. So an example for why we can or how we can use ginkgo in a behavior-driven development scenario. Imagine that we have a user story, a very simple user story. This is an example. As a dean, I want to know if a student is eligible for a scholarship, so that I have enough information to prepare the scholarship's budget. Okay, it's very simple. This user story defines 4 acceptance criteria. Given a student that is part of the medicine program and the GPA is over 80, then it's eligible for a scholarship. And there are another cases. Okay, so why I prefer ginkgo and gomega? Ginkgo first offers a BDD style testing framework, but offers a lot of functions like describe, context, when, it, and many others that allows us to create tests based on these acceptance criteria with a little effort and are very human readable too. Okay, and Gomega is a mature assertion library. Yeah, it's very similar to the assert package of Testify. But this API helps us to represent expectations in this acceptance criteria. So the combination on ginkgo and gomega allows us to create tests that are very close to the language used in the acceptance criteria. So let's go and see an example of this. This is an example for the first acceptance criteria, and here we are representing the checking scholarship eligibility. When the program is medicine, we create a context that is the AND operation of the acceptance criteria, and the GPA is over 80. Then the then will be the it in ginkgo receives the scholarship, and inside the it, that is the test itself, we can include the expectations from the gomega. So as you see, it's very easy to read this test and match that those 2 tests are part of the first acceptance criteria. So this is the idea behind behavior-driven development, to make easy this match between acceptance criteria and tests. Well, the func test section, it's a requirement to connect the ginkgo+gomega to the Go testing tool. So it's a function that we need to add. But the really important part is the describe section that we are creating here, the acceptance criteria that will be executed as test in our test suite. So this is all. I share a couple of links and reference. The first two are very interesting. The first is the test-driven development by example book by Ken Beck. It's a very important. It's a must to read a book for testing purposes. And the second one is a very interesting page, XUnit patterns. So with these two assets, I think that we can start with testing practices. And well, there are links for Testify, ginkgo+gomega, and that's all. Thank you very much for joining me in this session. If you have any question, you can find me using my nickname fdaines, or send me an email to fdaines@gmail.com. And remember, as a gophers, we have many options to make tests, to create tests. So just go and put this in practice. See you another time. Bye.